Hello. Today's paper is quite interesting in its own right. It's not super scientific, and at first I wasn't going to review it with you, but then I thought, why don't we dive into something maybe a little bit simpler, but maybe the beauty of this work is in its simplicity. So let's take a look. Today we're looking at drinking water treatment with UV light for travelers. Evaluation of a mobile lightweight system. And actually the whole focus of this paper is just to offer a third-party, independent, unbiased evaluation of a thing that's available on the market. Where's the science? Well, there isn't much, but it's quite important, and I really appreciate the approach the authors took here. They actually took a off-the-shelf device that travelers use to disinfect their water using UV light, and they verified the claim that the manufacturer makes. Well, how wonderful. Maybe there should be more of these studies, and I envision this as a wonderful project for maybe advanced undergrad group or like a senior design course, something like that. This is a really good idea. Let's verify manufacturers' claims. So anyway, in this study performed by Aachen University in association with some alpinism group association from Switzerland, they looked at Steripen, which appears to be on the market relatively successful device that's claimed to be able to disinfect water. So let's take a look. The authors took E. coli, Staph aureus, and a spore former. These bacteria are highly resistant to temperature, and they evaluated the ability of this Steripen to disinfect. And looks like when you use this Steripen as indicated and correctly, so read the manual, don't throw out the manual, make sure you read it, because if you use this guy correctly, you get 99.99% of bacteria and 99.57% of spores inactivated perfectly well. That's 1 out of 10,000 surviving. So you have 10,000 bacterial cells and only one survives the treatment versus maybe 1 out of 100 in this case. But if you don't agitate the water like Steripen suggests, you get 94.98% germ reduction, or even worse in certain cases, as the authors show. Here, 5 out of 100 survive. This is already something that could be potentially harmful to you. The bottom line of this paper to me is read the manual, and Steripen happens to be honest about their claim of 99.9% reduction of bacteria, viruses, and protozoa. Although authors didn't test viruses or protozoa, but more on that in a bit. So let's take a look. Interesting for me, a questionnaire-based study conducted in 2011 in the Everest region in Nepal showed that Steripen was just as frequently used as ceramic filters and iodine drops or tablets. Each method represented around 7% of the participants. So 7% use UV lamps, 7% use ceramic filters, and 7% use iodine drops or tablets. While 33% use chlorine, 24% boiling, 17% bought water, and 5% of people just don't do anything. So 7% use UV and 5% don't use anything. Love those numbers. But it's curious for me. I didn't think 33, 1/3 of the participants in this questionnaire who were climbing Mount Everest used chlorine tablets. Ugh. I mean, me personally, I don't like the taste of chlorine or the smell of chlorine or anything about chlorine. But that's just me. Oh, and this is what the Steripen looks like. So I guess it's a battery pack with some power that you dunk in a cup of water. Beautiful. And as I mentioned before, correct application of Steripen on 1 liter of clear water show reduction of phages between 99.7 and 99.9%, which is considered to be equivalent of 99.999% reduction of bacteria or 99.99% reduction of viruses. But this is studies that Steripen conducted themselves. However, papers published by independent peer-reviewed journals are scarce. Well, that is true. Most of these studies are funded by the manufacturer. So I guess there should be some kind of incentive for just consumers to evaluate this in their public universities. Curious. Have to dwell on that one day. There currently is no search results on term Steripen in PubMed as of October 2015. It's a product, so I guess nobody wants to evaluate it. People in PubMed publish pure science. Well, but this is something that we use when we climb mountains to sterilize our water. This is also important science, even though it's not high purity basic science that will win Nobel Prize, but this is quite useful just to regular consumers like you and I. So the authors say that, yeah, we didn't find any peer-reviewed papers on this, so we decided to do it ourselves. Furthermore, authors suggest geometry of Steripen might be less effective in slim, long bottles with narrow bottle mouth than in shorter, wider mouth bottles. So what they mean is in this figure too, like this kind of bottle versus this kind of bottle. Well, UV has to travel further, so its intensity will decrease. Curious. Authors attempted this, but didn't go all the way. Authors make an interesting suggestion that sun emits visible spectrum and ultraviolet light. However, most of UVC, more on that in a second, is absorbed by the atmosphere. So for this reason, microorganisms didn't have the opportunity to develop proper mechanism of resistance against UVC. Curious. So authors suggest that because UVC doesn't really get to Earth at sufficiently high levels, bacteria never evolved resistance to it. Possibly. By the way, when you write papers, be careful. People like me read them. So authors right here say UVA is ultraviolet radiation with wavelength of light in 315 to 400 nanometer range, UVB 280 to 315, and UVC 100 to 280, see figure 3. You look at your own figure. See this line here? So UVC is 200 to 280. Below 200 is called vacuum UV. It's called vacuum UV because it only travels in vacuum, because just atmospheric air would absorb it quite nicely. And so will all the plastic and the water and everything else. So that's why it's called vacuum UV. But it's funny that authors make this tiny little mistake. It's an honest mistake, but still, I catch those. Well, anyway, authors list advantages and disadvantages of Steripen. And let's dwell on that for a sec. So advantage, it's light. Cool. No chemical byproducts which cause an irritating smell or taste. What about ozone if you run it outside of water? But there's protection. You can't run it outside of water, so that's quite nice. Less time consuming than chemical treatments. Residence time of chemicals is between 30 minutes and 2 hours. So when you drop those tablets in, you gotta wait for a while. Versus 90 seconds of UV. Well, that's pretty cool. I think I'll go buy one of those, but you know, this channel is not sponsored by anybody. I'm just I'm just curious. Less time, less material consuming than boiling. Cool drinking water immediately after application. That's a good point too, that's an advantage. Disadvantage, fragile light bulb. Backup method necessary. What happens when you break a light bulb? This is 254 nanometer bulb, which is most likely mercury. So when you break this, now you have mercury all over your backpack. Where's that in the list of disadvantages? I digress. Lifetime of batteries is limited, so 4 AA batteries, 100 cycles. So if you use it to disinfect a bottle of water, well, you got 100 bottles of water. How long are you gone for? But okay, I guess extra set of batteries is necessary. On longer trips. Perhaps if you're gone for a month. But yeah, it's good to know. Does not remove toxins or heavy metals. This is common to all non-filtrating methods. Yeah, if you have many toxic, especially small molecule toxins, UV isn't going to do much. So that's a problem. And of course, doesn't remove metals or salts or anything like that. But maybe that could be a good thing, because you have artisan spring water that's pathogen free. Does not conserve the water. I did not think about this one. So chemical methods, the chemical remain in the water. So when you disinfect, drink a little bit, cap it, you can recontaminate it. Didn't think about that one, so that is definitely a disadvantage. And water needs to be clear, because any turbidity weakens UV radiation. So water needs to be pretty clear. The clearer, the better. Like melted snow, and not melted yellow snow, melted regular snow. So it may be necessary to pre-filter. Curious. Those are our bottles. Yeah, so for the safety of the user, Steripen is equipped with a water sensor which allows the light bulb to turn on only when submerged in water. What if I put a wet napkin around it? There are ways to trick that. Or there's a residual droplet and you pull out the pen midway. I wonder what they did to protect it. I'm just curious. I'll buy one just to look at it. So the test organisms authors used are just the standard E. coli, because it's a common component of water containing fecal pollution, like the poop bug. Staph aureus. Well, Staph aureus is a gram-positive. It's more resistant to UV due to its thicker wall, and in general, staph is also infectious bacteria. This Thermophilus spore is typically used for this type of evaluation because it's heat resistant. It allows us to test whether heat is the mechanism of inactivation. I love these kinds of statements. The spectrum of germs used in this study was limited to bacteria and bacterial spores, since viruses and protozoa require a much more elaborate test setup and different laboratory conditions. So we didn't do it because it's hard. Cool. I'm going to remember that. It's beautifully written. All it says is we didn't do it because we didn't feel like dealing with the setup. Good to remember. It's a nice thing to remember. There's another beautiful photo of Steripen upside down in a bottle of water that you must shake. Follow the instructions. And the authors used 3 different kinds of bottles. Wide mouth Nalgene bottle, aluminum bottle, SIGGTM aluminum bottle, and a disposable mineral water PET bottle. Each of them had a capacity of 1 liter. So what the authors did is, immediately after filling the bottle, they took a 100 microliter sample, then stuck a UV lamp in, and after 90 seconds took 3 samples. One of them directly underneath the water surface where the UV bulb had been situated. They called it top. 2 from the bottom of the bottle, and 3 they stirred the water thoroughly with a plastic rod, and then they called that sample mixed. Cool. It's good methodology, I think. I'm kind of doubting the validity of approach that the authors took with spectral analysis. Basically, they looked at the spectrum of the UV lamp by itself, observing lots of UV. Then they took the fiber and put it outside. And then they took the UV out a little bit and looked at different angles. Authors do not mislead you. They say that this is not the best method to use, but that's the one they had available. And based on it, they make some soft conclusions, which we'll come to in a minute. Table 2 summarizes the results of the test regarding the general effectiveness of Steripen. Let's take a look. So table 2, too much data. They show us all of their dilutions and reduction. How many times was this repeated? What's the error? Don't know. But averages, average E. coli, 99.996. So about 4.4 log reduction. S. aureus, 99.9933. Beautiful. Thermophilus spores, 99.5667 in this table. Less log reduction, but still pretty good. But I think they just showed us one sample. They do average. Authors also look at the influence of bottle type and importance of water movement. So they say that they reach at least 99.99% log reduction with vegetative bacteria when they follow appropriate mixing procedures. In contrast, not agitating the water during irradiation resulted in an average germ reduction of only 94.98%. Average of all trials conducted. How many? I sort of missed that. I think they mentioned somewhere that they did 3, but it's not immediately obvious. So that's something that I would mention more frequently if I was writing this paper. But anyway, the difference is clear. You have over 4 log reduction and less than 1 log reduction. In a case you follow the user manual and you don't follow the user manual. And how many of us would just stick it in a bottle and go? Probably I would. And I don't often read the manual, so this is a reminder to read the manual. This one's confusing. This is, I think, the only place in the paper they mention it. Finally, the effectiveness of stirring with Steripen inside the neck of a narrow-mouthed bottle was investigated. During this procedure, narrow-mouthed bottle. How do you stir in a narrow-mouthed bottle? It's got to be kind of difficult. During this procedure, the bottle itself was standing still. On average, this method of agitating the water only yielded a germ reduction of 88.93. So if it's difficult to stir, try to shake, but if you can't shake or stir, just don't use that bottle. But I mean, this is a careful study conducted years after the product has been on the market. So maybe Steripen should release bottles that work with their device. I don't know. This is a challenging marketing question. The spectrum they analyze and they see something that I would very much expect. They see beautiful line around 254 nanometers and a little bit of light noise. So this is definitely a mercury lamp. Authors also talk about UVC emission when used with a larger container like a cooking pot. A fraction of UVB and C radiation exits the water surface. So what they're talking about is if they're using this Steripen to stir a pot, when at a certain angle you would have part of the lamp outside of the water, but it's very difficult to measure, and all they're doing is measuring optical emission, which doesn't tell you the power of UV. It's definitely something that could be measured and it's not expensive or difficult to measure. I don't know how interesting it would be because in general, don't look at the UV lamp. Well, anyway, so the authors conclude their work stating that it is essential to agitate the water during irradiation. Yep, clearly, droplets present in the bottle cap or neck are not disinfected when using Steripen and are therefore a potential source of recontamination. So many graduate students forget this. When you have a bottle and a bottle cap, I have somewhere here, there, cap. If you autoclave the bottle but didn't autoclave the cap, well, the cap can contaminate whatever's in the bottle. And potential there is very, very high, especially if you had some bacteria present in that water to begin with. According to the manufacturer, the Steripen only yields proper disinfection results if the water is clear. Thus, turbid water needs to be filtered before application of the device. This is for travelers collecting water in streams and a mountain. What is your definition of clear? It's not very clear to me, pun intended. But in general, if you can see through it, UV can go through it. But that's a very general statement. So if the water is dirty, maybe run this Steripen 2 or 3 times. It's only 90 seconds per run. I love it. Watching the Steripen light through the wall of the plastic or glass bottle can be considered non-hazardous. Yeah, sure, water and plastic absorb UVC. You're not going to see it outside of the bottle, but still, don't stare at the UV lamp. Can't be good. It's not a good idea. If it's sticking out a little, you'll be getting a nice dose of UVC right in your eye. No, just don't do it. It is yet unclear whether UVC radiation Exiting the water surface when applying the Steripen in larger containers, e.g. cooking pots, poses a health risk for users and bystanders. It's unclear. Thanks. Yeah, well, we need to measure it. And authors do say that this is something that needs to be measured. Interesting thing to mention right at the conclusion, while this paper is dealing with drinking water hygiene, other methods concerning the prevention of travelers' diarrhea are of course equally important. There are preliminary reports on the use of alcohol-based hand gel sanitizer, which show at least a partial efficacy in preventing gastrointestinal infections. Wash your hands. We've been learning this over the last couple of years, right? Drink clean water, wash your hands, wear a mask when around a whole bunch of possibly sick people. Yep, things like that. New preventative methods, including the use of Steripen or hand gel sanitizer, are promising and have potential of increasing popularity among travelers. They should be further evaluated in the context of the prevention of travelers' diarrhea. Absolutely. Absolutely. Completely agree. Finally, conflict of interest. Authors state that they have no conflict of interest. Tests were conducted without knowledge or support of the manufacturer of the Steripen. And yet the results are awesome. So if I was Steripen, I would send them a box of chocolates. I don't know if that's considered a conflict or not. But I still probably would. Or at least a thank you email. Just really nice. It's nice overview. I liked reading this. Beautiful pictures. Really relatively simple work. Not published in a very high-ranking journal, but still it's probably nice to do this over summer with some high school students maybe, or do this in the US as part of a research experience for undergrads, a research experience for teachers. We're going to have plenty of such projects. We don't have to do science for space travel. We can do science for analyzing what things claimed in a grocery store actually work. Anyway, it was fun to review this paper with you. If you like it, click subscribe and click the little bell icon so we see each other more often. And I'm looking forward to reading many of these papers together with you. Do let me know in the comments if you have any questions, any suggestions for things you'd like to see in the future. Peace. Thanks for sticking around.